we're going to be looking at is finding the volume of a prism. Now, a prism is a shape that has two bases, and the two bases are a constant distance apart. We call that the height. The volume can be found simply by multiplying the area of the base times the height. So the things we have to find are the base area, and then we have to find the height, with the height being the right angle distance between the bases. Now, it doesn't matter, as they're showing here, if the prism itself is a right prism, which means that this is a right angle here between the base and the height, and it's perfectly vertical up, or if it's what we call an oblique prism, meaning it's slanted somehow. It really doesn't matter. The base area is still the base area. The height is still the distance between the bases. It's just that we have to kind of measure the height sometimes on the outside to get that. It's a right angle distance. So those are two things we need to find the volume. In fact, once we found those two, we simply multiply them, and then we use our context, which in this case is units cubed, because volume is measured in cubic units. So essentially, there's four steps we have to deal with here. First, we have to decide what the base is. Next, we have to find the area of that base. Third, we have to find the height. And then finally, we just do the multiplication. That's the easy part. In fact, a lot of times, the hardest part is finding out what the base is. Now, a prism, like I said, always has two bases. And those bases are non-rectangular sides, except in the case of a rectangular prism. We learned about that when we were naming yesterday. For example, here I have a triangle prism. And on the right side here, that is a trapezoid prism. Zoid prism. There we go. So the base is the non-rectangular side. This gets a little confusing when we have rectangular prisms, but actually those are the easiest cases. So once I know what the base is, once I've decided what the base is, there are a couple things I want to do. I want to identify it, and I could identify either of the two bases, because there's always two bases in a prism. Okay, so identify my base, and this is the area I've got to find. So I've identified my base. Now I got to find the area of the base. Well, the base is a right triangle. So the area of the base, that area of that triangle is base times height divided by 2. Now, different base, capital B base is the area of the base. Lowercase b is a smaller base of a triangle. So 3 times 4 divided by 2, which is 12 over 2, or 6 centimeters squared. Then you need to find the height. The height is the distance between the two bases. It's usually given. And I simply multiply them. And you'll notice the units work as well. If I could take, a lot of times people just multiply the number and remember the units, but I'm going to put the units in here. It's 6 centimeters squared times 2 centimeters. The 6 times 2 gives me a 12. The centimeters squared times centimeters gives me centimeters cubed. And that's the volume of this triangular prism. We could do the same thing for the trapezoid prism. Step 1, the base is a trapezoid. And the formula for the area of a trapezoid, in case you have forgotten it, because this is something that is carried over from other books in the Big Ideas series, but in case you've forgotten it, the formula for area of a trapezoid is height over 2 times base 1 plus base 2. That's the formula for area of a trapezoid. So in the trapezoid here, this is the base one, the long one is 14. This one is 6, so that's 14 plus 6. The height of the trapezoid, not the height of the prism, is 3 centimeters. And I just do the math on that. That's 3 halves times 20. And that reduces, so it's 30 centimeters squared. So there's step 1 and step 2. You might want to jot down this formula if you don't remember. I'm going to try to get a podcast created that actually reviews basic area formulas. So do be sure to look for that in the resources in Schoology if you're not having difficulty remembering basic area formulas for different shapes. Step 3, find the height of the prism. Okay, not the height of the trapezoid, but the height of the prism. And again, it's a little confusing because I got 2 different heights I'm dealing with here. But here we're talking about the height of the prism, the distance between the bases, 5 centimeters. And once I've got all that done, the rest is easy. We simply multiply the base area times the height of the prism, and I get 150 centimeters cubed. Okay? That's the way it works. Cylinders. Cylinders are not prisms, technically, because the base is not a polygon. The base is a circle. But you want to know what? The formula is exactly the same. It works the same way as a prism. The volume is still the base area times the height. It's just that the base area is now a circle. So we can get a specific formula for this because the area is a circle, pi r squared height. But it really is the same formula. I mean, we could do specific formulas for triangular prisms. We could do specific formulas for hexagon prisms and trapezoid prisms. We could develop 100 different formulas if you want, but really the only one you really need to remember is base area times height if it is a cylinder or a prism, because they work the same way. So the same steps, we identify our base, we find the height, or find the base area, find the height, multiply the base area times the height. So let's practice a couple of those. Again, 1, the base is a circle. Step 2, the area is pi r squared for a circle. So pi times 9 squared is 81 pi feet squared. Now again, kind of like we did with circles before, if it's a nice whole number like that, we're going to leave it in terms of pi. If I had some sort of decimal value, then I would go ahead with approximate 3.14 for pi. But 9 is a nice whole number. We're going to leave it that way because it's precise. 3, find the height of the cylinder this time. And that's the distance between the bases, right there, 6 feet. And 4, we take base area, capital B, times height. That's 81 pi feet squared times 6 feet is going to give me feet cubed, obviously. Whoops, that's my units, that's my context. 81 times 6, 6 times 8 is 48, 486, that's going to be pi feet cubed. Don't forget the pi. If it's a circle, you get pi. Don't forget the pi. It's really easy to forget the pi. All right, let's look at the second one. It's oblique, it's slanted, but the technique is not going to change at all. Step 1, circle base. Step 2, area equals 4 squared times pi centimeters squared, or 16 pi centimeters squared. Step 3, the height equals 7 centimeters. It's the distance between the bases, the right angle distance. And so the area, step 4, they should put down, sorry. Step 4, the area equals 16 pi centimeters squared times 7 centimeters. 16 times 7 would help if I hit the right buttons on the calculator as I'm trying to do this quickly and I'm failing miserably. Is 112 pi centimeters cubed. I say area, I meant volume. There we go. And that's all it takes. It's really not that bad. Okay, here's one for you. Find the volume of a solid. Now, it's a little bit tricky, so I'm going to give you a little bit of an assistance here because this is a rectangular prism. So essentially, any side could be my base. But when any side can be my base, I'm usually going to try to choose what I think appears to be the bottom. So let's use this as my base right there. So you work through the 4 steps and find the volume. Here's another one for you. It's a cylinder. The base should be obvious to you. So you work through the 4 steps and find the volume. One final application, and this is working a little differently. You know the volume, you need to find one of the other dimensions. And this is where it gets kind of interesting. But again, we just kind of work through things backwards, okay? I know the volume. I know what the base is. I mean, the base is this rectangle right here, okay? Kind of got a little bit messy with it. Everybody get the idea. So we still have our steps. The base is a rectangle. The base area is length times width. 6 times 4 equals 24 feet squared. The height is unknown. That's what we got to solve for. But I know the volume, step 4, the volume is 72 feet cubed, which is the base area times the height. And the units are even going to work out here for me. So if I know my formula, I can simply divide by the 24 feet squared. Whoa, hello. That was an interesting way to make a 2. And 72 divided by 24 is 3. Feet cubed divided by feet squared. Remember our unit cancellation, it's like x cubed over x squared is just feet equals the height. Even the units work out for me. Even the context works perfectly mathematically. So it's just kind of using the formula to solve for the unknown part. It works pretty nicely. And you'll see some problems like that too. In fact, we'll see more like that. So there we go. Volume of prisms. Welcome to the adventure.